Hello everyone. Welcome to this video lecture series on computer organization and architecture. Today's topic is CPU, main memory and IO units. So after this lecture, you will be able to learn about the main component of a computer system, including CPU, main memory and IO units. You will also be able to explain the internal organization of CPU in terms of ALU, register and control unit. Not only that, you will be able to describe the role and characteristics of main memory and its interaction with CPU. You will also be able to differentiate various IO components and data transfer methods that are widely used in a computer system. Finally, you will be able to illustrate the interaction among CPU, main memory and IO components using block diagrams. So let's start. So the first question is, what is computer organization? Normally we hear the two terms computer organization and computer architecture. So let us discuss what are the differences between them. So computer organization means to organize different units of a computer. What does it mean? It means several operational units like CPU, memory, input, output components, how it works together to execute a program. That is the main goal of CPU organization. The main difference with computer architecture, this philosophy, so computer architecture focuses on programmer visible features. It means whenever we are discussing about computer architecture, so it is something like how a programmer is looking at the computer, and computer organization means how a hardware engineer is looking at the computer. So these two aspects are different. So if you look at this diagram, so a computer system actually has four basic functions. So namely data processing. Okay, so this is data processing, then data storage, because it is very important to store the data, not only process it. Data movement, from one place to another place data needs to be moved, and how all these processes will be controlled. So for that we need a control mechanism. So repeat once again that a computer system is organized to perform four basic functions. What are those functions? First is data processing, second is data storage, third is data movement, and the final is the control. Now if you look at this diagram, so with this operating environment means the users who are operating the system or the network which is accessing the systems. So for that, this data movement unit have a bidirectional connection. So data movement apparatus can give data to that unit or operating environment. The operating environment can also give data back to the data movement apparatus. Okay. Now when the data movement apparatus, it takes the data, then with control mechanism again it is having some bidirectional connection. So what does it mean? So this data movement apparatus can give data to this control mechanism block, and also the control mechanism block can give back data to this data movement apparatus. So a similar bidirectional connection exists between data storage facility and control mechanism, and at the same time data processing facility and control mechanism. So computer is such a device where this data processing, data storage, data movement and this control unit, they interact with each other in a bidirectional manner. So let us start with central processing unit or CPU. So central processing unit, as the name suggests, it means all the processing tasks are performed there. So that is why CPU is the core component of a computer system. This is the core component. And this core component is responsible for executing instructions and control all the system operations. So executing the instruction means what? Executing the instruction means what? Suppose I am telling the computer to add two numbers, to move one data from one register to another register. So these are all called some instruction that the programmer or user is giving. So CPU is responsible for executing such instructions. And during that process, how this operation will be executed, this is controlled by the CPU as well. So therefore CPU has two major components. The first component is called arithmetic and logic unit, that is ALU. So this ALU performs arithmetic operations. It means addition, subtraction, multiplication, division. These are all arithmetic operations. And what are the logical operation it performs? It performs addition and operation, or operation, not operation, and comparison operation. Okay. Next part of CPU is registers. So register means what? We know about attendance register. Attendance register means what? Where the attendance of the student is stored. That is called attendance register. So similarly, in computer also, registers means some small high speed storage location inside the CPU. It means we know about memory. So memory is something that is connected externally to the CPU. But within the CPU also, there are some small high speed storage location. These are not called memory. These are called registers. So in which purpose these registers are used? Basically, these registers are used to store instructions. So whenever a CPU wants to perform some instruction, so there should be some place where this instruction will be stored. So there are instruction registers. There will be some registers to store the data operand. So we will come later that what is called operands. So basically operand means on which the operation takes place. That is called operand. Okay. Some intermediate results. So when CPU is performing some operation, so in different steps, it produces some result, and sometimes we need to keep a track, or we need to store these results in the middle of the process. So these are called intermediate results. Whenever some data needs to be taken from some memory address, and say after the operation we need to send the data back to some memory, so these memory addresses also needs to be registered by the CPU, and these memory addresses are stored in the register. So registers are not memory. So I would like to clarify that registers stores the memory addresses. These stores only addresses. I mean, these are not memory. These stores only addresses. Now some commonly used addresses. So program counter. Okay. So what is program counter? Program counter means whenever you have given some program to the computer, So line by line the programs are getting executed. So for example, this is line 1, this will be executed first, then line 2, this will be executed first, and so on. Now when line 1 is getting executed, okay, so the program counter actually stores the address of the next instruction. So this is the role of the program counter. So if we take one analogy, so suppose uh, we want to go to market so to purchase three items. So for example, three items are milk, vegetables, and grocery. Okay. So suppose first I go to the milk shop, so I purchase milk. Then if I forget that after purchasing milk, what is my next destination, then I will stand in front of the milk shop round the day if my next destination is not fixed. So this is the role of program counter, that after I have purchased milk, my brain will remind me that my next destination is vegetable shop. And after I complete purchasing vegetables, my brain again reminds me that my next destination is grocery shop. And after the grocery items are purchased, so my final destination is my home. So in computer also, program counter does the similar job, that when an instruction is executed, it tells that what is the next address of the instruction. So this is called program counter register. Next, the instruction register. So instruction register means it stores the meaning of the instruction that needs to be executed. Not only that, it also have some general purpose register. So whenever suppose I am adding two numbers or subtracting two numbers, uh, or suppose temporarily I need to store some uh, result, so I can use these general purpose registers as input or output registers. Okay. So for example, temporarily I need to store, suppose 2 plus 3 is equal to 5. To compute this operation, so first I need to store 2 to some general purpose register. I need to store 3 to some general purpose register. So suppose 2 plus 3 is equal to 5. I want that this uh, result to be obtained. So suppose I am first storing these 2 to some general purpose register named R1. I am storing this 3 to some another general purpose register R2, and after the operation is done by the arithmetic and logical unit, then finally I am storing this value to register R3. So these type of registers are called general purpose registers. Okay. Now status or flag register. So what are this? Status or flag register. Suppose my system uh, has a limitation in bits. All digital systems have some limitation in their bit count. Okay. So suppose for example, my system is a 2-bit system. Okay. So 00 01 10 11, these 4 results only can be obtained by my system. Suppose this 0 means 0, you know that 01 means 1, this means 2, and this means 3, you all know that. So in a 2-bit system, I can store only these 4 values, either the result will be 0 or 1 or 2 or 3 after any arithmetic and logical operations. Suppose I want to add 3 plus 2, then what will happen? The result will be 5, but 5 cannot be expressed. Okay. 5 cannot be expressed in a 2-bit system. So that is why what is happening, 1 bit overflow is taking place because I need 3 bits. So when all such instances are actually happening, so these instances are recorded in such registers, those are known as status register or flag register. Then comes control unit. So control unit is, you can say that this is a manager of the computer. Okay. So it fetches instructions from memory. because in memory, if some instructions are stored, so it will fetch that instruction from the memory, and then also then it will decode the instruction. I mean, it will extract the meaning of those instructions. So accordingly, it will generate control signals. Okay, and it it is a coordinator. I've told you it's a manager, so it coordinates among the ALU, register, memory, and IO devices. It synchronizes all of them. Okay, so these are the purpose of control unit. So it is very important that whenever computer is making some operations, so all this input, output, memory, all registers are in good synchronization. So this synchronization is maintained by this control unit. Also, there is one important feature that this control unit ensures that the instructions are executed in the correct sequence. Okay, so this is also very important, that why the instruction needs to be executed in a correct sequence. So in later modules we will explore that why the sequence is so much important, and if the instructions are not executed in sequence, then what types of hazards it can bring into the system. So that is why this control unit is very crucial in those applications. Now, internal CPU interconnection. So all CPU components are connected using some interconnects. I mean, the pathways through which they are connected to each other. So these are known as buses. Okay, these are known as buses. So what is the role of buses? So buses are some interconnection or connection pathways through which all CPU components are connected, and it allows very fast transfer of data and the control signals within the processor. So the data processor needs to be fast, we all agree, but the control signals also needs to be very fast. Otherwise, unnecessarily the system will be in idle condition. Okay, so the data is available, but as we don't have any instruction that what to do and how to do, so the system will be idle. So that is why these CPU interconnections enable that feature, that whenever all components are connected, so in between them there is fast data transfer exists and fast control signal transfer exists as well. Now let us come to the concept of the main memory organization. So what is memory? Memory means that stores some data. Now in computer, different types of memories are used. Okay, some memory is very tightly coupled or very placed very near to the central processing unit. Some memory we can separately place on the motherboard, and some memory are there which we connect externally through some ports. So based on that, the memory are actually three types. So broadly, three categories are there for memory. So first is called inboard memory. Okay, inboard means these memories are built on the motherboard of the computer. Next is called outboard. Okay, so outboard means this can be placed inside the computer, but it is connected externally to the main board. And finally is called offline storage. Offline storage means, suppose a pen drive, when we connect the pen drive, or suppose some external hard disk drive that we connect to the computer through some ports, so these are known as offline storage. So let us focus towards the inboard memory. So what are the different types of inboard memory? So in inboard memory, see, there are registers. So already you know that registers are part of the CPU to store some data temporarily. Then comes cache memory. Then comes main memory. Okay, so these three types of memory are part of the inboard memory. Okay, So cache memory is such type of memory that is in between these registers and this main memory. Okay. So after that comes outboard storage. Outboard storage means magnetic disk, CD-ROM, okay, DVD read write, DVD RAM. These are called outboard storage. It means it remains within the computer cabinet, but it is a separate board. It is not the main motherboard. And this offline storage, so already I have told that suppose you are connecting some pen drive or USB drive externally to the computer. So these are all the examples of the offline storage. So magnetic tape, okay, USB storage, all are the examples of offline storage. Now you might be wondering that why this memory are actually ordered or arranged in a pyramid shape. So basically this is called memory hierarchy. So hierarchy means what? Some levels, some arrangement in levels. So in main memory organization, how this hierarchy plays a crucial role. If you travel from this tip of the pyramid to this bottom, then what will happen? So in the tip of the pyramid, registers are there. So registers are the fastest memory. Fastest memory. The speed is fastest. If I come to this bottom of this pyramid, then this magnetic tape and USB drives are the slowest memory. These are the slowest memory. So one learning from this hierarchy is the memory that are located towards the tip of the pyramid, those are faster, and the pyramid and the memory those are located near the bottom of the pyramid, those are actually slower. Okay. So now you can tell that register is the fastest, cache is slower than that, main memory is further slower than that, this outboard storage are further slower than that, and these magnetic tape USB drives are the slowest. We get another information from this. If you are near the tip of this pyramid, so registers are fastest, but it has the least capacity of storage. So least capacity of storage. Least capacity of storage. But if you travel down from top, these offline storages have the largest capacity. And another information is that the memory that is fastest, actually these are costliest. And the memory those are slowest, actually those are cheapest. Okay. So if I go down by the hierarchy, the cost per bit decreases, the capacity increases, the access time increases, and the frequency of access, that also decreases. So that you need to remember when you learn about this memory hierarchy. Now let us come to the context of input and output components. So suppose mouse is an input device, monitor is an output device, and all are interfaced to the CPU. Now how this interconnection is possible? So basically IO modules play the role. So this IO module is an interface that is placed between the user and the system. Now through three interconnects, namely address line, data line and control line, these IO modules are connected. So this is how they are connected. So suppose if I am using one keyboard, so keyboard means we know some keys are there, but it's not like that. The keyboard needs to be interfaced with the CPU properly through address line, data line and control line. And main memory will be having a role there, because main memory also shared the three lines or interconnects. So keyboard should be connected to CPU through keyboard interface. Printer should be connected to CPU through printer controller or interface. Any disk should be connected through the CPU to the CPU through disk interface, and any monitor should be connected to the CPU through some monitor controller or interface. So what are the function of these IO modules? So IO modules perform the control and timing of IO operations, because when multiple IO devices are connected to the system, it is very important to control the access properly. It enables the communication with CPU and memory. Also it enables some temporary buffering of data. If there is any error in the communication, so it also detects and corrects the error. Okay. Now how a computer transfers data from IO devices into it? So there are three philosophies or three techniques. First is called programmed IO. So programmed IO means when multiple IO devices are connected to the computer, the CPU all the time it monitors the status of the IO devices, and CPU is actively engaged in controlling the data from and to IO devices. Second is called interrupt driven IO. It means CPU is not engaged all the time with the IO devices. So whenever any IO devices wants to communicate with CPU, so it sends one interrupt signal. This is called interrupt request. Now when an IO device requests interrupt signal, now the CPU gives an acknowledgement, and if that device is ready, then the further communication takes place. So in this case, CPU is not all the time engaged. So whenever an IO devices requests, so the CPU handles that IO devices accordingly. And the third technique, which is the most efficient technique, that is called direct memory access. So in this case, the data is transferred directly between memory and IO devices, and here the CPU involvement is minimal. So this is an independent process, so where data is transferred directly between memory and IO devices. So already we have discussed this system level view of computer organization. So now in system level view, what are the different types of registers? So first is memory address registers or MAR. So it specifies the address in memory where the next read or write will take place. Just like program counter gives an idea that what is the location of the next program to be executed. So memory address register gives the memory address for the next read or write. Next is called memory buffer register. So it contains the data that needs to be written next into memory or which needs to be read next. So there is another register that is called IO address register or IOAR. So it specifies a particular IO device address, and also there is some IO buffer register. So when some IO device wants to exchange some data, so before the transmission it stores that data. So through this interconnection, so when an IO devices transfer data from external devices to CPU and memory, so there is a memory module that consists of a sets of location. So each location will contain a binary number. Okay. So these binary number can either be instruction or data. And IO modules contain internal buffer. Why? Because the data needs to be stored temporarily. So this was all about the basic introduction to CPU, memory and IO devices. So we learned that a computer system consists of CPU, main memory and IO components, and they are interconnected through a bus. The CPU performs instruction execution through ALU, register and control unit. And we also learned that the main memory stores program instruction and data that is required during execution. The IO components, they enable the communication between computer system and external devices. There are three types of data transfer mechanism between IO device and memory, that is called programmed IO, interrupt driven IO and DMA or direct memory access. And if the coordination among CPU, memory and IO is well, then the efficient coordination is possible for the overall system performance. So this was all about today's lecture. Thank you so much for attending this.